Hi everybody, this is our third video for Chapter 5. We've learned two methods for solving systems of equations. We learned how to solve by graphing. We were finding the intersection point. And then in the previous video, we learned how to solve using a method called substitution, where we solved for a variable and then we substituted what it was equal to into the second equation, and we solved for a single variable. We plugged it back in, and we got the second value for the second variable. So the elimination method is somewhat similar to substitution in the fact that we're not graphing anything. We're still solving algebraically, but it's a little bit of a different strategy here. We're still solving for the intersection point, okay? We're just getting it a different way. It's a different strategy. So the elimination method actually has us adding or subtracting the two equations, and we keep them stacked, with the goal being that we want to eliminate or cancel out one of the variables, either x or y. So we have some steps, and the first step is we need to make sure that our equations are lined up. So if you think about a system of equations, we want the top equation to line up with the bottom equation for the x's, the y values, signs should be lined up, and your numbers should be lined up. If they're out of order, you're going to need to rearrange them before we can continue with the elimination method. Once everything is lined up, we're going to either add or subtract these two equations, and we're going to have to decide which we're going to do by looking at the coefficients, the numbers in front of the variables. We want to always cancel out the variable that has a common coefficient, meaning in the top and the bottom equation, the same number is found in front of the same variable. Once we add or subtract these two equations, we're going to be left with an equation, and we're going to solve that equation for the variable that's left, and then we're going to plug what that variable is equal to back into one of the original equations and solve for the other one. So let's see what that looks like. System of equations. Doesn't look any different than it did for substitution, okay? But instead of solving for one of these variables, we're going to try to cancel one of these variables. We want to look for the variable that has a common coefficient, meaning it has the same number in front of it for the top and bottom equation. Well, our x's have common coefficients because both of them have a coefficient of 1. So we're going to try to cancel the x's. So we have to decide if that requires addition or subtraction. So I think about it this way. If I were to add these equations together, 1x plus 1x would give me 2x. Okay, that's not canceling it out. To cancel it out, we need to make it a 0x. So instead of addition, we're going to use subtraction, because 1x minus 1x gives us 0x. But we don't just subtract the x's. We have to also subtract the y's and our numbers. So 4y minus a negative 1y is really like 4 plus 1. So this would really make a plus 5y. Our equal signs drop down, and then 13 minus 3 gives us 10. So here's our new equation, but here's the thing. If I have 0x, I don't need to write that. The equation that I'm really left with is just 5y equals 10, and to solve this, we know that we should just divide both sides by 5. So pretty quickly, we found what y is equal to for the solution of this system of equations. To find the x value, it's just the same way that we did it for substitution. Once I know one of them, I plug it back in and I find the other. It doesn't matter which equation we plug into, okay? Either one's going to give us the same answer. So let's go with the bottom equation. We've got x minus y, which is negative 2, equal to 3. Well, if I have x minus negative 2, that's the same as x plus 2. And then we would find that x is equal to 1. So our solution is 1, 2. So let's take a look at another example. Remember that we're trying to cancel out the variable that has a common coefficient. So looking at our system of equations here, it's the x's again that have common coefficients. Okay, but this time, one of them is a positive 4x and the other is a negative 4x. Whenever you have the same number but different signs, you're going to add to cancel them, because 4 plus a negative 4 is what makes it a 0x. And then we add the y's and the numbers. So the equation that we really have here is 16y equals 16. We divide by 16, and we get y equals 1. So to find the x value, we're just going back, taking that y value, and plugging it into one of our original equations. Again, it doesn't matter which one. Let's use the top equation this time. We have 4x plus 9 times y, which we just found was 1, equal to 5. So we're solving. We really have 4x plus 9 equals 5. We subtract 9. We divide by 4. And we get negative 1. So the solution to the system, remember it goes x and then y, is negative 1, 1. In this example, both of our variables have common coefficients. So let's see what happens for this problem. Let's cancel the x's. To cancel the x's, we would have to subtract. Anytime you have two of the same sign, meaning they're both a positive 3, you have to subtract to cancel. So when we do 3x minus 3x, it makes 0x. When I do negative 4y minus a negative 4y, remember, be careful with the negatives here. If I have negative 4 minus negative 4, that's the same as negative 4 plus 4, which is 0. So this is interesting because not only do we have a 0x, we also have a 0y. And then negative 10 minus negative 13, remember, it's like we're adding, so negative 10 plus 13 makes 3. But here's the problem. If we have 0x and 0y, that means both of our variables have canceled, and that means that the left side of our equation is really just 0. So we don't have a variable left to solve. We're left with 0 equals 3. Okay, but that's not true. 0 does not equal 3. So think back to when we were doing equations at the beginning of the year. When we ended up with something like this, where our variables canceled and it wasn't true, we said that the equation had no solution. And this is an example of what no solution looks like for the elimination method of solving systems of equations. So we can have no solution. We can also have infinite solutions. Now, for our next example here, we have a problem. Our x's and y's aren't lined up. Okay, in the top equation, we have our x and then our y and then our equal sign and then the numbers. But the bottom equation isn't in the same order. So we're going to have to rearrange this. We need to get x and y on the same side. So we're going to subtract 2x from both sides. Now, let's go ahead and just rewrite our system of equations. The top equation is not changing at all. But the bottom equation now, in the correct order, would be negative 2x minus y equals positive 10. So from here, we can do our elimination steps. Let's cancel out the y's this time. So if we're adding these two equations together, we get 2x minus 2x, but we have a problem. That makes 0x. And when we do y plus negative y, that makes 0y. Also, when we do negative 10 plus 10, we get 0. So at the end, we end up with no variables to solve for. We're left with just 0 equals 0. This is different than the previous example because this is an actual true statement. So the difference is, instead of no solution, this means we have infinite solutions. Now, the next two examples we're going to look at are slightly different because we're not going to have common coefficients to start with. We're going to have to create common coefficients by multiplying one or both of our equations by some number. So here's an example of what I mean. Our x's don't have common coefficients. Our y's don't have common coefficients, so we have to make them. And looking at this, it's going to be much, much easier to get a common coefficient of x than it would be for the y's. I personally prefer to always add my equations if possible. So if I want to add my equations to cancel x, I'm going to have to have opposite signs. So I'm going to multiply by a negative 2. Now keep in mind, we have to rewrite our system of equations here. And when we do this, we're multiplying our entire top equation by negative 2. Meaning we're going to get negative 2x minus 6y equal to negative 12. Everything gets multiplied by negative 2. Our bottom equation hasn't changed at all. So now we're at the step where we can add our equations and cancel out x. So negative 2x plus 2x makes 0x. Negative 6y plus negative 7y makes negative. Negative 12 plus negative 1 makes negative 13. Now, we know that this is really just negative 13y equal to negative 13. We divide by negative 13 and find that y is equal to positive 1. So now we go back, we pick one of our original equations, and we plug it back in. So let's use our top equation here, the one before we multiplied by negative 2. So we have x plus 3 times 1 equals 6. And we find that x is equal to 3. So our solution is 3, 1. All right, one more example where we don't have common coefficients. All right, we have a 9 and a 2 in front of x. We have a 3 and a 1 in front of y. So it's going to be easier to get a common coefficient on y this time. So we're going to multiply our bottom equation by negative 3 so that we have a positive 3y up top, a negative 3y in the bottom. That way we can add our equations and cancel out the y's. So let's rewrite the system. The top equation is not changing. The bottom equation is getting multiplied by negative 3. And since we have the opposite signs on y, we're going to add our two equations to cancel. So 9x plus negative 6x makes 3x. The y's cancel. And then 12 plus negative 15 is negative 3. So we divide by 3 and find that x is equal to negative 1. Once we have x, we know that we need to go back and plug it in and solve for y. So let's plug it into our bottom equation before we multiplied by negative 3. We have 2 times negative 1 plus y equals 5. So that's really negative 2 plus y equals 5. We add 2 to both sides. We find that y is equal to 7. And we have our solution. It would be negative 1, 7. All right, I hope this video was helpful. Please ask questions, pause, rewatch, rewind, and have a great day.